trickle-down government, I guess Romney coined on this presidential campaign, that's not too far off from what this is about. So government spends money initially, and then it trickles into other people's pockets through the economy. So what I want to think about first is a consumption function. Consumption function. So, what part of GDP does consumption make up? How large of a part of the pie is consumption? 70%. So yeah, a large fraction of what goes on in the economy is due to consumption of households on final goods and services. So we're going to have a basic form of how that consumption goes on, and it's dependent upon their income to some degree, and then also non-income elements. So we're going to write that out, putting our equation goggles on, as A plus B y. Slope-intercept form of a line. So consumption in this equation is a function of income, gross income. I'm going to leave taxes off for now. And then some fraction of our income gets spent, and we call that the marginal propensity to consume. The marginal propensity to consume. The MPC. So right now, Y is, of course, our income. And this little floater out here is just saying if our income was 0, we'd still have some consumption from other sources of non-income. Money that we had, savings, other things from previous time, gifts from other people. A lot of countries depend on the United States for regular gifts to them, right? So we're going to lump that all into one category called autonomous consumption. And it's simply consumption that's not dependent upon current income. Not dependent upon current income. So a couple simplifying notes for right now. We're going to keep things very simple as we build this, and we're going to say that there's no taxes yet. We're going to complicate it later, but no taxes. So recall, something we did last time was thought about our disposable income. What was that? Disposable income. I think we did it last time or the time before. Might have been 2 times ago. Money after taxes. Good. So all we're going to do is take our income, our disposable income, is equal to our gross income minus taxes. And we had a couple other variations of that formula that we had last time. So mathematically, we're kind of saying, we wanted to be kind of geeky mathematician, economist people, we'd say let t equal 0. Oh, you guys get an extra credit point. Let's see, pull out a piece of paper. My mother-in-law. I won't answer it because then you guys will get another extra credit point. All right, on your piece of paper. But did we already do Rust Busted before? Was that this class or was that a different class? Oh, see, that was a different one. All right. So go ahead and put Rust Busted, put your name, and get you guys an extra credit point. Look at that, you're 1 point up on the final already. Things are looking up. Okay, so taxes equal T equals 0. So from equation standpoint, this thing drops off. Gross income equals disposable income, right? No big deal. All right, so we got taxes equal to 0. And I want to take this graph, or take this equation and graph it out. So next step is to write a graph where we're going to measure total spending, planned expenditures, and income. On the horizontal axis. Over here, we're going to write planned expenditures. What we're planning to spend. So expenditures are spending. So help me out. How do we graph this? Look at that equation. It's slope-intercept form. How do we graph it? Upward sloping, good. It's a good start. Where does it start? The origin? A starts at A. So we have some amount of spending even if our income is 0, right? The autonomous part. So go ahead and put a little A here. And then as we earn income, we spend more. So like you said, it's upward sloping, and it's a line. What's the slope of that line equal to? What is it? B, or the marginal propensity to consume. So here's our consumption function. Let's just put a C here. And maybe just note that the slope is equal to the marginal propensity to consume, which was our little letter B from the equation. So whatever, however you want to put that. I guess I want you to know that it's the marginal propensity to consume, not just B. That'll turn out to be important later. Okay, so there is our consumption function. All right, so where we're going with this is that there's more than just C to explaining the spending going on in the economy. So what are the other parts? What does total expenditures equal to? If we look at the entire economy, we've got consumption, investment, good, government spending, and net exports. So we've got the rest of the players to come into the picture. So if we look at our basic model, consumption by households is the big part we just did, but then there's investment, government spending, net exports. Good old cigarettes. So how do those play in? All right, we're going to make a couple other assumptions here and talk about different types of spending. So we had autonomous expenditure through that little A factor. So we've got autonomous expenditure or spending. So underline autonomous. I think, did I already define it for you? Did I say spending not dependent upon income? Mm-hmm. Okay. So we're going to assume that investment, government spending, and net exports are also autonomous. And another word that's similar, that takes on a little bit more of a math flair is you can also think of these also known as, AKA, exogenous shocks. So the word exogenous in terms of an economic model means something that's happening from the outside coming in. So an external factor, it's an independent variable essentially, kind of explaining something that's going on. So exogenous, now let me go ahead and add another bullet here, I guess. Some outside external factor that impacts the dependent variable. In this case, our dependent variable is spending. More specific, I'll get into what type of spending. All right, so then a separate item to think about is what we call induced expenditure. And this is where the multiplier kind of ramps up. Induced expenditure. So how this ties into the multiplier is that a government expenditure of $100 million on weapons of mass destruction ends up in the pockets, ultimately, of somebody else's wallet, and they go out and spend that money. So the initial injection of this exogenous shock, the initial spending of $100 million on weapons, induces other people to spend when their incomes go up. So that's the distinction, induced versus autonomous. And so induced expenditure is spending that varies with GDP or income. I'm putting that in parentheses, just remember we're using that interchangeably here. Your income, GDP, just like we had the whole semester. So spending that varies with your income, that's how this thing's going to kind of shake out. All right, spending that varies. So kind of the key point here is that autonomous spending can lead to more induced spending. A multiplier effect. Okay, so as we start to add on fixed pieces to the puzzle, and we start bringing on another factor like A, so if investment is $50 million, what happens to this endpoint if we now look at C plus I? It goes up, and then it's a parallel shift up. So that's all we're doing to build the model. So once we get a little more sophisticated, if this ends up being an amount equal to a change of I, and so this is essentially A plus I now is this endpoint, and it's a parallel shift. This is now the C plus I line. And if we add in the government, that's going to shift it up as well. And so this is the C plus I plus G line. And this endpoint is A plus I plus G. So we're kind of keeping the math fairly simple. Kind of explain this multiplying process. I'm not going to add exports for now. We're just going to leave this off. So we're going to have what we call a closed economy for this model and just pretend that only the United States exists. We're going to forget about the rest of the world. Okay, so this looks like this. All right, I'm going to now redraw, and you might want to redraw as well, a single line that represents our spending, planned spending. Okay, so I'm just going to do this. Now that we got the concept, hopefully. We've got, you guys can just kind of redraw that. We're going to have a closed economy, another assumption here. No exports or imports. Just to keep things simple. More simple for now. All right. What happens in equilibrium? So this is planned spending. Here's real GDP. So do we always get the right things equaling out in the end of our income being equal to our expenditures? And yes, that's right. So no, in the short run, if we go back to our simple flows, I've been hammering at this all semester, our income equals our spending. But we've already talked about those timing lags, and so what's the deal? How do we account for maybe the timing's not perfect over a given, in a particular situation of where our income and spending might not be equal? In the long run, we expect them to be equal, right? Income equals spending is what we've been thinking about. So if I was to draw a line that showed all possible equilibrium points where income equals spending, kind of the long run possibilities. If I was to draw a line that showed that, what would it look like? 45-degree angle, right? So a 45-degree line shows all points where income equals spending. So this is not a function at all, it's just a definition. So we're going to actually call it the 45-degree line. It's a reference line that shows all points where income equals spending. So 45-degree reference line shows all points where income equals spending. So this would be all kind of long run equilibrium points. So you can imagine here that this is a special, all the exciting stuff seems to happen where the two lines cross in economics. So at this point, income equals planned spending, which I'm going to, I think, just call total expenditures, PE, just to give a shorthand notation here of what our planned spending is. Okay, so things are not necessarily in equilibrium. And so let's look at some disequilibrium points. What if we're not there? What if the economy is slumping? And so let's call this our potential level of real GDP that we've been talking about. Like, let's say the potential for the economy is there. In the long run, we'd be there. But we fall into recession. What's going on at Y1? What type of gap was that, by the way? Which that was a different model that I showed that. Recessionary gap. So our current level of output is less than our potential, a recessionary gap. The amount of spending is higher than our actual amount of income. So spending's higher than income. Now the key new thing we're going to bring to the table with this is inventories. What is inventory? Stock, right? Stock at the companies. Unsold goods that they have on their shelves, right? So that is sitting there as not the dollar value of all final goods and services sold within the nation, right? It's just sitting there as part of the investment category. So the inventory of finished goods ready to be sold are sitting out there. If our inventories, or if our situation looks like this, what's happening to those inventories? If spending is greater than the amount of final goods and services that are actually out there being sold, if we're tending to spend, what's happening to inventories? Are they falling?
They're falling.
They're falling, right? Spending is higher than what's actually out there. Inventories are falling. When inventories fall, what do businesses need to do? Ramp up production and restock, right? So they go to work and start restocking, and that generates income for people. So what we're going to kind of tell a story of is how inventories fit into the picture in the economy, and how ultimately that would get us back to where we'd expect to be in equilibrium. So at this point, spending is greater than production. So at Y1, spending on goods and services is greater than production. How can that be? Well, because we have inventories as kind of a buffer. So spending is greater than production, which means inventories of final goods and services, maybe I'll write that all out. Inventory of final goods and services, mostly final goods, by the way, but inventories are falling. This is then a signal. Inventories are now a signal to businesses to increase production. So that's going to move us this way. So over this range, the inventory is falling. over this whole wedge over here. If the economy is at a higher level, what type of gap? Inflationary gap. We're not talking about inflation here, by the way. This is spending and income. We'll come back to that later. But now we have production higher than spending. Inventories are increasing. A lot of stuff on the shelves. They call up their manufacturing plants and say, halt production, we don't need as much. I know we ordered 1,000 last month, but this month we only need 500. Right? So they slow down production. So there's an increase in inventories. Inventory are increasing over this range, which signals us to cut back on production. All right, so at Y2, production is greater than spending. So there's an increase in inventory. Signal to businesses to decrease production. All right, so all of these are kind of arguments as to why we're heading back to some level in equilibrium. Go ahead, Max.
Is the 45-degree line similar to the supply curve or not?
No, not in this case, because it's, I mean, we're at least talking about production here, and so we're going to show a model later where we'll link this graph to that other one, to the aggregate demand, aggregate supply graph. So, but no, it's just showing this possibility of the timing of spending and income and kind of
It's not measuring production necessarily.
Well, it's measuring it here in terms of production and income, but it's not dependent upon price, or because we're measuring inflation or price over here, not just planned spending. So that would be the difference.
Is it possible for the consumption line to be steeper than the 45-degree line, never intersecting?
No, and the reason is, well, what is the slope of the 45-degree line? 1, right? It's 1-to-1 relationship, so up 1 over 1, up 1 over 1, right? So the rise over the run is 1. What's the slope of the consumption function? The slope was the marginal propensity to consume. So I haven't quite got there yet to talk about savings, but can we consume more than 100% of our income? Not with outside sources, right? So, this thing could get like this, but not greater than the 45-degree line. Especially in aggregate, where we're, we can bring in borrowing, but there has to be somebody on the other side of the equation that's doing the lending. Yes, Chelsea?
Like what initially causes the increases or decreases in inventory? Like what initially would cause it to go from potential to Y1 or potential to
Probably expectations would probably be one of the leading things, but current profits could be as well. So those are the animal spirits that Keynes would be thinking about, is that we got entrepreneurs out there that are rolling the dice, going for the big bucks, trying to make money, and so they're making these adjustments based on what's going to happen next year. And so if they're optimistic about the economy, some of those companies might be increasing inventories now, and they haven't sold them yet. And they haven't necessarily, they also might have produced them expecting to get $100 per unit, but at the end of the day, the public doesn't receive them as well, and they end up selling them for 50 bucks a unit, right? So expectations end up playing a big role. All right, anything else? Okay, so we need to work out this multiplier business. I think I'm going to redraw. I don't want to leave the inventory picture. Okay. Go with blue. So we're going to measure production there, total expenditures, total planned spending over here. Ooh, I'm burning through mine. Ooh. Okay. So draw your 45-degree line. And this is really total expenditures. Now maybe we can do it a little bit different, but C plus I plus G. Consumption's at some amount, investment, government spending. I'm just going to put, I just put little zero subscripts. So now I'm going to spend $100 million on weapons of mass destruction. So I'm going to have the government increase spending to C0 is going to stay the same, investment's going to stay the same, government spending is going to go up to G1. And they are ramping up a change in government spending equal to $100 million. Okay, so here's the story. We start here at, let's just call it Y0. And we end here at Y1. This is hard to see visually, but you can deduce this with even this sloppy graph. Is this distance from Y0 to Y1 equal to this 100? Or is it greater? It's greater. So if you do this little chunky here, watch this, rise over run, right? You get a bigger bang for your buck. That's going to bring the multiplier process into it. So we went up by 100 million, but we got more than 100 million in income. And that's going to ultimately be the multiplier concept coming through. Okay, so how do we get that? Let's do a little exercise here. So we get a change in income of $100 million. That is the exogenous shock, the change in government spending of 100. I'm going to make a few columns here. So we get 100 million. Is the initial shock to the system. Got to fight off the bad guys in the Middle East, so we need more weapons, so we do it. How does that change? What does that impact in the system? Somebody's going to get to go run to Walmart by people who work for the weapons plant owners, all the resource suppliers that supplied the metal and gunpowder and other things to the weapons plant, right? All those people are benefiting from the U.S. government kicking out $100 million to buy some new weapons. So their consumption is going to change by some factor. How much of that $100 million are they going to spend on consumption? It's kind of a loaded question. I didn't give you an exact number. It's not 50%. It depends on, taxes are 0 for now. Good thing to bring out. The marginal propensity to consume. I was just looking for a generic answer. The marginal propensity to consume. So let's say that the marginal propensity to consume is equal to 0.1. I'm sorry, 0.90. In other words, people tend to spend 90% of their income. So the change in consumption is 90. So what happens to the 90 worth of spending? So all the weapons people took their money and spent 90 of it. They saved 10. Where did it go? It went to other places, other Applebee's, Walmart, other places, right? So it ended up in somebody else's cash register. It's now somebody else's income. Now those people get paid, and they consume 90% of it. So 10% gets shaved off, 9. So now there's a change in consumption of 81 million. Those people run to their places they want to blow their money. 81. So then, what do we get here? I don't know if I can pull this off here. 70. Who wants to help me out?
72.9.
72.9. Good. And so on, and so on, and so on, and so on. That's the multiplying process. So the big question mark is, what do we get at the end of the day? Well, we can do a Microsoft Excel spreadsheet, add up the totals. That would be one way to do it. But some mathematician, I can't remember who to give credit to. This is a Taylor series. Who's my math guy? Curtis, do you remember anything with the series of things going? So we could do some elaborate formula and come up with something, but you don't need to know that, because some mathematician told us that the change in income is going to be 1 over 1 minus the marginal propensity to consume times the change in exogenous spending, which was awfully nice of him. I do remember it's a male. It might be Taylor, a Taylor series. And so 1 over 1 minus 0.9 times 100 million gives me 1 over 0.1, which is 10 times 100 million, or 1,000 million. Alright, 1 over 0.1, which is 1/10, flip it over, the multiplier is 10. Very similar to something we did. The deposit multiplier was 1 over 1 over the required reserve ratio. So this little part here can be rewritten a little bit. 1 minus the marginal propensity to consume is also equal to the marginal propensity to What are you doing? Saving. So, marginal propensity to save the MPS. Oops, I guess I don't have to rewrite MPS. I already did. So that you could just say 1 over the MPS is the multiplier. So when we talk about the spending multiplier, that's it, whatever that number is. This is the spending multiplier. In the most generic terms, it's the autonomous spending multiplier. I put G here, but that could be any change in autonomous spending. For example, investment. Right? So a change in investment kind of trickles through the system the same way. So note that this is any type of autonomous expenditure. And let me put any autonomous expenditure. Change in investment, change in government spending. So 2 ways to think about the multiplier. So sometimes a test question might say, suppose that the marginal propensity to consume is this, what's the multiplier? Or another test question might say, suppose that the marginal propensity to save is 0.2, what's the multiplier? So you could use either way. All right, so the change, back to tying this back graphically, under those assumptions of the marginal propensity to consume, the change in Y, the amount we ramped up by, is equal to 1,000. 1,000 million, otherwise known as a billion. So $100 million worth of weapons led to a $1 billion increase in spending. All right, so that is called the simple multiplier. Key point. 1 over 1 minus the MPC is the simple multiplier. It gets complicated when you add issues like tax rates, little t, and your ability to buy from China instead of the United States acts as a leakage out of our little system. So the marginal propensity to import, the MPI. So we start bringing in imports and tax rates, and this thing gets a lot uglier. We'll pick up there next time.